Okay. Hello, everybody. This is Fermin Serrano from Zaragoza. Just to verify, could you all write your something in the chat saying that you are hearing me? Okay. Can you hear me, all of you, please? Let me. Great. Thank you. Okay. Thank you very much for joining this virtual excursion to the ViSH Research Institute in the University of Zaragoza. ViSH comes from biocomputation and physics of complex systems. Okay, we are a multidisciplinary research institute created 10 years ago, mostly composed by physicists and biochemists. Okay, we started mixing the approaches in the theoretical physics area devoted to the analysis and development of proteins with for drug discovery. Okay, we are addressing for pharmaceutical issues here. So we mix two major approaches: computing facilities, computing laboratories, and biochemistry laboratories. Okay, in the sense, one of them, the computing laboratories, are in silico simulations. And in laboratory, we do the in vitro phase of the analysis. Okay, we started having one single group of computing in the computing area here, devoted to high performance computing, and now we have expanded the kind of paradigms that we use here, and we are in several. In grid computing, cloud computing, high performance computing, and myself, I am the research leader of the volunteer science computing, which is a new idea, a new paradigm, mostly devoted to take advantage of external resources composed by the computers of the people, the smartphones of the citizens, and so on, and compare those external resources to the performance of our internal resources. So I guess somebody is having problem. If you don't mind, I keep on talking, okay? So that we don't miss the time schedule. Okay, Enrique, should I keep on? Sorry for my English, first of all. I try to do my best with my intonation and my pronunciation, but it's okay. So I guess you are
your
all...
English is good. Thank
you very much. You're very kind. I shared one website from our website at bifi.es website, where you can see the laboratories with a kind of plan of our building. We have several buildings, but major headquarters are here in Zaragoza. You can scroll down in this website and check all, for instance, area .20 means ground floor, area .21 first floor of this building, and 1.2 the second floor where I am here now. Okay. So, for instance, if you want to see one, you can check whatever you want, and you will see if you click on the map on any of those laboratories or rooms, you will get a picture of that laboratory. For instance, let me show you one of the laboratories, which is the X-ray diffraction lab, which is you can see one single machine at the end of the laboratory. This machine is used to check the structure of proteins. Okay, very pure proteins, isolated proteins. They put an array of X-rays and they check the diffraction so that they know the structure of the protein. Okay, the physical structure, the 3D position of each atom and peptide and so on. Okay, for instance, I will present later the microscope used in the cells experiment, and it is located in this room also. Okay, just another link for another chromatography laboratory. Okay, it is hidden because that microscope needs to be dark in order to check the fluorescence of applied to the cells and so on. Okay, let me keep on moving in this. I want to present mostly the computing infrastructure we have here. Okay, I don't know if you are aware of what infrastructure means. It's a general concept referring to the infrastructure made to do. The infrastructure are used to make e-science. What is e-science? It's a new concept addressing disciplinary international research, addressing complex problems, which requires big facilities, I mean big sensors like CERN, for instance, big ICT resources in order to deal with the data. For instance, the grid computing network distributed supercomputer in order to deal with all the collisions that happens at CERN, and also the big network of sensors like we had in Doñana. I don't know if some of you were present in the virtual excursion of Doñana. Okay.
Yes, so, some of them were there. Yeah.
Oh, that's nice. That's nice. So I want to show you the. Let me share in this URL, please. And you will need to introduce a password. Okay. The user is Excursion, and the password is global. And here you will see. Thank you, Enrique. In this tool, you can see the supercomputing facilities in this building. Now you are watching three different racks. This is a 200 meters square room. Let me move the camera. I can control it. I guess you can't. And you see different racks of computers. They don't have screens and keyboards, but those are real high-performance computers. Indeed, the one you are watching the scene now is extremely fast and extremely expensive machine. We call it Memento, and it is a shared memory machine. What does? Sorry, somebody cry. Sorry, let me get back to the URL. I want you to check the. Enrique, can you put again the camera? Thank you. That machine is devoted to a kind of scientific problems which require huge interaction between nodes. Okay, I refer to node to one single process, one single software program. Okay, running one application. Sometimes the softwares are isolated; they don't communicate each other. But sometimes they pass messages, they share inputs and outputs, and this kind of machine is extremely fast for this kind of problems, where a lot of programs, a lot of computing threads are addressing the same problem and the same set of data. Just to give you an idea, virtually this machine has, well, no, physically there are more than 300 computing cores, 3,000 computing cores, and they share a virtual RAM memory of 12 terabytes. 12 terabytes of RAM memory. That means that they address very fast to the same region. And why we bought this machine? It was almost 1 million euros. This machine is used to simulate drugs and proteins. Okay, in the sense that
said it cost more than 1 million euros.
Almost 1 million. Yeah.
Almost 1 million euros. Wow, that's a lot.
Yeah. Yeah, we fund this with regional funds from Europe. Okay. The software we are running here is the drug discovery, okay? Because the proteins, we have the 3D dimension of the proteins, and we insert a new compound, a new peptide, for instance, which is the actual drug. with which we want to modify the effect of the protein. For instance, we have the protein, sorry, here, and we want a little peptide to be plus in the middle in order to modify the behavior of the protein. The interaction of each atom, each part of the protein with this molecule, which is the drug we are trying to discover, requires a huge effort of computation, a huge interaction between atoms, for instance, microgravity and so on. Okay, and that's why this machine is very useful, and we are running very fast there. Marisa is having some problems. Sorry. The rest of you can hear me, okay? So, for instance, let me show you another example of machine. This machine you have in the middle is grid computing. This is connected to CERN, and we are receiving data from the CERN, from the Large Hadron Collider, sorry, where the bosons are colliding, and they check the effect on the geometry of the collisions and so on. They send us some of the results there, and we calculate in this kind of machines, okay? Somebody remove the link.
I shared the URL again because Tina said she was saying.
Okay, thank you very much. At the end, what I wanted to show with this computing room is the complexity of these machines, okay? We spend, just to give you an idea, around 100,000 euros per year in electricity. 100,000 per year in electricity. It is an expensive bill. It is useful for many researchers, but the current trend in supercomputing is to create green high-performance computing, okay? In order to decrease the regular costs. If we move from, I said, there is one computing machine devoted to one specific domain of programs, okay, like shared memory machine. The same thing we can address with volunteer computing, which is somehow my domain. Volunteer computing is, the idea is basically connect all the desktop computers in your house, in your desktop, in your office, connected them virtually via internet, installing one software who said, I am connected to this server, for instance, for SETI at home or Folding at home or IBS series. We are one of those servers, okay? When they connect to us, we can know the kind of processor, the kind of the amount of RAM memory, the hard disk memory they can share. We know several things about the computing core, okay? So we send them some simulation process, again, some software we have with simulation programs, the scientific programs. We send to the volunteers these pieces of software of programs so that they execute this software at home and they get back the results, okay? At the end, we had an alternative computing infrastructure externalized with low consumption because we take advantage of existing resources, with low maintenance cost for us, because if somebody change the software, change the keyboard, or if anything happens at home, it's not our issue, okay? It is a common computing scenario in the world. Most of them are in the States and in Europe, but it is going up in number. I think there are more than 2 million people connected in this kind of projects, okay? 2 million people is a lot of them in the last 10 years. No problem at all, no security issues arose, because the software you install in your computer is, yeah, the screen is empty, yes. Let me share
There's
you
no problem
again.
with that. I think it's a problem with the camera connection.
Oh, really? I thought somebody removed that. Sorry. So let me
No, no
show
problem.
you.
You can continue. We had a question from Barbara. Is
Yeah,
this
please.
the most expensive equipment machine you have? This that 1 million, almost 1 million euros, or you have
No,
more
not really.
equipment?
The most expensive, it's very nice because it is one. Let me share the URL again. Oh, come on. My chat has disappeared. Can you share, please? Oh, thank you. Here again, the camera. The most expensive machine is more than one. It's 1.5 million euros. We bought that 8 years. No, 8 years. No, in 2008, almost 6 years ago. Can you share the? Can you
No,
check
maybe there is a problem with the connection.
Okay, let me send you at least the picture from. Let me share you. Yeah. Well, in this picture, you see again the laboratory. The third machine at the end, it's called Janus. Janus is a dedicated supercomputer, and it was created by us in the sense that we created the scientific program that was going to run in there. We created the computer, the processor itself, made by FPGAs, which is FPGAs are reconfigurable processors. Okay, so we programmed very detailed program in order to take advantage of this infrastructure, of this processor. Okay. Let me show you the computer. It's Janus is composed. You can see here one motherboard with 16 square. All of them are FPGAs. We had 256 FPGAs running one single application for 7 years already. Okay. And I get back to the temperature. Yeah. So
which is the temperature of the room? I suppose you will have air conditioning there and that kind of things.
Yeah, we were spending a lot of money, as I said before, because the machines require a margin of temperature between 24 and 36. Okay, more or less. The problem is the hot condition and the dry and the humidity of the room. Okay, so we have a control in the scenario. The last work we were redesigning the infrastructure some months ago, and we created a free cooling system. Free cooling means that we take the air from the street, the cold air from the street, we use it to refrigerate the machines, and the warm air goes again to the street. Okay. Why do I say there is one flow of work of air? If you have seen the picture, we have two different corridors. Okay, imagine of racks of machines like this. The cold corridors are in the left and the right, and the warm corridor is in the middle of because the flow comes from here, refrigerates, and the warm is removed to the street. Okay. So in the warm corridor we have 60, 70 degrees. It's important to take it out as soon as possible. And the cold corridor, as I said, we are 25, 30 degrees. Okay.
Have you ever had a problem with the temperature of the room?
Yeah, definitely. Yeah, because we have sometimes electrical power cuts, and the refrigeration stops, and we have to stop all the computing cores. There's a mess for the researchers and so on. Yeah, it's a hot topic. A lot of machines now are already refrigerated by water, by liquids at the motherboard level. Okay, so there is no airflow as in our
there are
normal
special
computer
machines.
with bands and so. But yeah. I was some years ago in the most important supercomputer in China, the Tian-1A, which was the top one, and it was totally silence in the room. There were no noise of refrigerator, and our room is very noisy indeed, because we are moving a lot of air. Okay, so
Okay.
I want you to know, have you visited virtually the e-infrastructure, the room? I want you to know the inner part. How do the system administrators, the programmers, and the scientific users use those machines to perform their researches and run their programs? Okay. The most accessible monitoring tool we had is the map of ViSH, which let me show you here. You can see a map, a Google map, typical. You can do a scroll and so on. You will see some logos in Spain and Portugal, and some orange dots around them. These are the dots. Each dot is one user connected to us, and I don't know if you will be able to see. We are monitoring the launch of works from our side to the clients and so on. In this map, you can play the sound. We perform a nice experiment here. If you press play in that map, you will hear the feeling of the e-infrastructure, in the sense that we have a common sound during time, like a chord of piano. And if some events arise, like we have run one application of Fusion, we have run one work unit of amyloid research or whatever, or a new client has connected to us, in that case we launch one phrase of music. So at the end, in some performances, we were listening live to the brain of this. Are you watching the ballets from ViSH to some of the clients? Those are the work units.
I saw some from Madrid to Trujillo, I think it is, or Cáceres?
Yeah, it is Trujillo, indeed. Yeah, in Cáceres.
Trujillo, right.
Yeah. We are the ballets we send from the missile from Zaragoza to the volunteers are the work units we send, and when they send ballets to Trujillo are the results they are giving us back. Okay, the results. But well, this is just an artistical approach to the monitoring. The status, let me share this new URL. Okay, you have here a monitoring tool developed by us and controlled by us, where you can check the number of jobs, of scientific jobs created by researchers and being sent to the volunteers. Okay, there is one combo box. It's called. I forgot. If you check where it's written BinSurf, you can check Biosoft also and Conjeturas. There are 3 different applications which are being run at this moment. Again, BinSurf, for instance, is a new application which is analyzing again the interaction of proteins with proteins, interaction between proteins and ligands, but they are using graphical processing unit, GPUs, like NVIDIA and so on. And it is Biosoft. It's a very nice application. If you check in that combo box, how do you say that combo box? No, I forgot the name. But if you check Biosoft, you can see the number of several graphics in the right part, okay, with green and blue colors and so on. Are you all of you in Biosoft application? Here we control the number of work units ready to send the number of results, and when do the volunteers send us back the results, and so on. Okay, it is important for us to control it, because at any time we must have work units to send to the users. It is very important that the volunteers don't have their processor idle, because they want continuously to contribute with us. It may okay, goodbye, Marisa. Thank you very much. We send continually work because they want to get some credit. Okay, we are giving the volunteers credit units, and there are many competition and karma in the world saying I am contributing to several BOINC projects, I have this number of credits, I am the user of the week, and so on. Okay, and they want continually to have their contribution useful for science, and that's why we are continuously sending scientific works. It is important for us. Okay, so this is an open visualization. The last URL. Let me show you another monitoring tool we use in ViSH, our own system administrator. And this time you will see the core of the machines you have seen before. Okay, Nagios is used for most of the e-infrastructure, competing e-infrastructure in the world. And I guess you need to log in again. In Nagios, yeah, again you have the user Excursion, the password global. Okay. So in that URL, the problem is that I cannot send you directly to but you have a menu in the left of the screen. I want you to click on the map link. Okay, the map. What does it mean? At any time in the map, we can check the status of either cities in Zaragoza and in the rest of cities where we have servers. We have several servers in order to have load balance, okay, in order to have redundancy. If some system fail down, we have another as backup, okay, in order to continuously send and receive the results and the work units from the volunteers. Okay, if you click on map, you have a kind of tree, a graph with one important node in the middle called internet. If you go to the left, you see the switches, the networking tools we use here in Zaragoza in order to move the work server. Okay, at the end. In the leaves of the tree, you see several nodes. It's not completely shown, but you have database.ibercivis.es, 15f.harrequest.org, webserver.ibercivis.es. So you see there all the machines, all the services we require in order to create one single experiment of BOINC. Okay. As you may imagine, it is not trivial to set up the infrastructure. It takes some months to understand.
Do you have any kind of alarms here if any system fails?
Yeah. From the internet node, if you go to the left, you have the Zaragoza machines. Okay. If you go to the right, you go to Portugal, switch.portugal, for instance, or switch.zciemat. Basque Country, and also we have machines in Madrid, in Red Iris, in CSIC, and so on. Okay, so yeah, definitely we have a complex scenario here. If you click, as you click it on the map link, I want you to click on the host group. Okay, host. Groups link. If you click on the host groups, you see again all the hosts, all the machines,
yeah,
and the status of these machines. Okay, how the host, all the services running on each machine, as you may imagine, one web server is running several services. One to deliver the website, one to deal with the database of users, one to deal with the database of computing units, and so on. Okay, there are different experiments, different frameworks, different infrastructure under all these machines. Okay, so you can scroll down and check all. This is the inner part of the machine. If anything fails, you can check that the flags are not green, are red. I see, for instance, in resultados, which stand results in Spain, there is one critical, one partition, for instance, is not running down. One disk has failed. Okay, I'm sure. Well, this is controlled. This kind of alerts are sent by SMS to the system administrators, so that they can check at any time using this tool what happened, where happened the problem, and how to deal with it. We are not, unfortunately, we are not rich. We are not a private center with a lot of people working. And if something happens during the weekend, most of the time they have to wait until Monday. And but also several times there are volunteer effort from the people here. Okay. What else? I don't know if you have any of you have ever seen the monitoring tools of an infrastructure. Do you have any question or something now before moving to another part of the session? Please, any question?
No, I think you can continue.
Okay, so as I said before, we have a controlled scenario in our data center here with our facilities, our computing infrastructure, our microscopes and our biochemistry laboratories, experimental laboratories. Okay. My domain indeed is the volunteer science, and it addresses the uncontrolled scenario. Okay. The usage of desktop computers at home is one of the examples, but we can also consider the sensors from any of you. We can consider the human themselves as external sensors useful for make science. Okay. If you were in the visit of Doñana, they had a great example of controlled sensors, controlling the humidity, the temperature, the ground, the birds, the position, and so on. Okay, it is a controlled scenario. What happens if we take advantage of the mobile phones of any of you in order to communicate with the volunteers, people at home, in the countryside, wherever, in order to ask them to act as sensors for us. Okay. For instance, we have one example to monitor the influenza, the flu in Europe. Okay. You can control the flu in most of the cases in real time with the hospital data and the health ministry of each country. The problem is we want to analyze the evolution, the peaks of the flu disease. Okay. For instance, you can go in Spain or in Britain and check what happened each month, the number of diseases, and so on. No? The evolution in each country. The problem is that the format in Britain is not compatible with the program in Spain. And it makes not possible to create complex models and validate those models with experimental data using the formal data, the official data. Okay, so we created one network of volunteering. Let me say you, sir. It's called Influenza Network, influenzanet.eu. We have several. Oh, sorry. We have several countries connected. If you check, I think it will. Carlos, which message? I don't know why I can't visualize now the influenza. Anyway. No, it's okay, thank you. As you can see, there is a map of Europe, again, with all the countries connected, and there are more than 41,000 volunteers connected. We're asking a simple question to the people. Do you have the flu or not? Okay. Of course, we have some profile information requiring the where do you work? Do you work isolated or with a lot of people? Do you have kids in the kindergarten, for instance? Do you work facing a lot of people, and so on? Okay. Do you smoke? This kind of profile is asked to the volunteers, and at the end, periodically, we ask them, tell us if you have the flu or not. This network is working very well, and you can check that the peaks and the evolution of each country, it's totally equivalent to the official data. The good thing here is that we can model at European scale the influenza, okay, and the dynamics. What happens usually if some peak arise in Portugal, then moves to Spain, then to France, then to Belgium, and so on, okay? A lot of people say, well, but your data are not validated. The experience says that we don't need to validate the data from the human sensors as it is correct, okay? We contrast with official data and it's correct. For instance, okay, if you go to the doctor, yeah. No, it's not a regional program.
Is it a regional program?
No, it is European. Each country has its own application. For instance, there is grippenet.pt. There is also grippe.
Okay.
Grippe.
You can click, if you click on the on the flag. Yes,
yeah,
if you click on the flag, you will see a link to every country, right?
Yeah, definitely.
I access grippenet from Spain. But in Spain, you only have 600 participants. In other countries, I see that there are more than 6,000.
Yeah, we launched that some months ago in November. We didn't prepare public and dissemination activities because we were the last country entering in this network, and we wanted to have a controlled number of people in order to check that all the servers deal okay with the data, and there are no problem with legal data and so on. Okay, yeah. So the idea here in this project is that each country has its own application, always sharing the data and publishing things together. Okay, but it is one. I like this just because it is one example of researchers who said, I need experimental data to validate my models. So I address the people directly to contribute and perform a teeny task, just saying I feel fine or I'm sick at home with the flu. Okay. There are other contributions from people which can be useful for the science. We are addressing, for instance, in a couple of experiments, the happiness of the people, or the comfort of the people. Okay, in order to know the temperature at home, it is very easy to understand the temperature, the humidity, the noise, and so at the end, and there are some standard measures of the comfort, but it is not clear that those standard comfort measures are okay for all the people. So we can ask directly to the people, what is the temperature in your room, and do you feel fine with that temperature? Is this comfortable for you? Okay. What about happiness?
So
it is very subjective. Right? Yeah.
There is another question from Wick and Mariana. How could one contribute on this application?
How could you contribute? Just log in your country and register. And I don't know if you can do it now. Sorry, because the influenza, the flu campaign lasts from November to April, and I think we closed the servers now, until next November, until next October, in order to ask people to contribute. But you can register now, and you will get some reports, some bulletins with news and some tips and advice and so on. Okay. I was talking about about happiness. There is one important trend now about the semantics of the web. Okay, how to analyze the web properly, how to recommend a book to other people. If you are reading this book, I recommend you to buy this other book, and so on. The semantics are very complex for machines. Okay, and we are addressing semantics to the people at home also. One tiny experiment, we ask you to analyze one Twitter, for instance, and say, this Twitter is very happy, or is very sad, or refers anger, or whatever. No, this kind of subjective issues are very cool for the citizen society in order to compare with control psycho test made in the past. Okay, but well, let me forward to another participation. Here we have seen the volunteer sensing. Okay, let me show you a volunteer crowdsourcing scenario where we ask people to perform some little tasks in the same way we do at home in the laboratory. Sorry, act as a researcher. Okay, you can see in this URL one of the objects which is linked to the ViSH hub in the global excursion. We are contributing in this application in order to ask people to analyze cell images. There are human cells, stem cells, sorry. And researchers at ViSH are analyzing the effect of some drugs or some toxic compounds, the effect of temperature on those drugs in vitro. Okay, so those vitro experiments are done in one microscope, and the pictures taken by this microscope are sent to the people in order to analyze them. It is very easy for the researcher at the beginning of the experiment, at the evening, usually one Friday evening, they put the experiment on the microscope, and they leave the experiment during the weekend, and on Monday they get back and say, oh my God, all my stem cells are dead, or some of them are dead and some of them are still alive. What is the critical issue? They don't know the dynamics of the experiment. Okay, so sorry, there is somebody talking here. I missed the point. Yeah.
Yes, the dynamics of the experiment is provided by people, right?
Es un momento. Mari Carmen, por favor. Mari Carmen. Please, you can talk. Por favor. Okay. Sorry. These pictures are analyzed by external people in a controlled scenario. Okay. If you click on the cell images in the start contributing now, you can see the images. You have also here in the left menu, info, contribute, export tasks, and statistics. We have also the monitoring tool here. Okay, but if you click on start contributing, I don't know if I have one question for you. Did one video tutorial appear for you or not? Because I think I go directly to the images. Okay.
No,
you go directly to the new task, to one picture with the cells. Okay, I guess. Okay. It depends on the IP, and sometimes you get the information. Here you can check several things in this screen. In the top right, you have the ViSH hub button, okay, to visit virtually the laboratory with the virtual excursion. You have some information pop-up about the task to perform in this screen. Okay, you can check the video of the experiment. That means during the whole weekend what happened. Okay, and you can also change the feeling of the picture, watching the green channel, the blue channel. There are several channels because several pictures are taken with different fluorescence, and different issues are good for the nuclei. They are painted by blue, mitochondria are painted by green, and so on. Okay. At the end,
so everybody can contribute to distinguish the kind of cells that are there, right?
Yeah. In this case, we are in a complex teaching scenario, and there are many steps we are asking the people. Okay, we are asking them. You can see all the steps, the 9 steps, in the bottom of the page. First, we ask them to tell us if there are alive cells or dead cells. Then we ask of the cell shape. Then if the cells are releasing content, one kind of death. Then we ask about the nuclei, if they are the nuclei, if they are still alive or not. The mitochondria shape, the mitochondria distribution, the mobility of the cells, and so on. Okay, so it is an interesting and real scenario. In this case, you can, I don't know, I guess you will have different pictures from us, but in my case, I see more or less 20 alive cells and 3 dead cells. Okay, you can check if they are alive or dead thanks to the examples in the right of the screen. And
so
if you check the number,
this is for people to help scientists because this can't be done with machines, right?
Yeah. These are real images taken in our e-infrastructure facilities here in the laboratory, and we need to know exactly what happens during the weekend. Okay, and we generate a lot of data, and we need a lot of people.
Is there a lot of people collaborating in this kind of citizen science, we could say?
Again, we created this just a few months ago. In February, in this case, and we launched regionally, locally, this experiment with the teachers in our region. Okay, we have 16 teachers running this application in their schools with their rooms, with the classrooms, and at the end we have around 700 students. Okay,
so students
some of
also collaborate, right?
Yeah.
So it's not so complicated. Yeah.
Well, it is complicated because we created complicated. For the next academical year, we want to improve the tool. For instance, by clicking with the mouse each of the cells and so on. Bye, Samar. Thank you very much. Now, what else? Yeah, well. They can contribute at any time in the school, also after the school at home. And the good thing here that we are going to give extra points in their final grade, so that they are motivated to contribute. Okay, but next year we want to promote this at European level. We invite all the teachers related with global excursion to join this, and so on. Okay.
Yes, there is a question from UPM. What tissue do these cells belong to?
Tissue means
tejido in Spanish.
Yeah. They are cancer de colon cancer. Do you know?
Colon cancer. Yeah.
Yeah. It's not very nice. Yeah. That's colon cancer from HeLa. Let me show you the link in Wikipedia. HeLa cells. Yeah. They are very famous, these cells, okay? These are the cells we are using here. If you want to check the video and more information about this in English, we have created a generic video here. I guess it is. Yeah, the first 3 minutes are generic.
All living beings
about...
are made out of cells. Plants and animals contain many different cells. There are also unicellular organisms made out of a single cell,
Enrique.
as protozoa,
Yeah.
yeast or bacteria. All cells are originated by division of
Can you
other
stop the
cells,
video,
except the first cell that
please?
appeared millions
I
of
think we
years
should
ago at the origin
change
of
the
life.
Let me.
Plants and animals contain many different cells.
Okay, let me share another link and it's okay.
Yeah.
Yeah, for instance. Yeah, it's okay. In the case you need to know more, we have that video, 5 minutes length. The first 3 minutes are generic for the cell and cancer and drug discovery processes. And the last 2 minutes are devoted to the experiment we are running with the students here, okay? And here you have further information in the link, in the ViSH website. You have different videos also and different description of the protein, mitochondrial, carrier, whatever. It's very complicated for me, sorry. And finally, I think we are running out of time, okay, because
Yes.
we will finish in 5 minutes. I wanted to show some other facilities at ViSH we have created in order to improve the teaching, which are also connected to, these tools are connected also to the ViSH Hub in Global Excursion. We have a laboratory, a machine with several devices, like a pendulum, a pulley, a spring, and all the people can virtually enter to the laboratory and perform experimental tests, real tests, playing the simulation parameter of the pendulum, of the pulley, and so on. And you can control the machine from your classroom, for instance, okay? That means that, for instance, you click on pendulum. Let me verify that there are different.
Yes, but I think we can't access all at the same time because of you have to reserve and to do a reservation.
Yeah, definitely.
But for the teachers attending this session and for the teachers that see this recording in the future, this is a very, very interesting resource just for your pupils. You can access it anytime, and you will be able to access a pendulum, a volume.
Sorry, Carlos, what is that? Maybe the translation, or you don't see the link.
We will send yes, the link is not seen because if we share it in the chat, it is shared between everybody. But we will send it is rrlab.bifi.es. But we will send also a report with all the links and all the resources that you can access with your pupils in the future that we have shared and that Fermin has explained.
Yeah, Carlos, that is the URL.
Yes, that's the URL.
Yeah, sorry, I forgot that you cannot access at the same time than me. But yes, please try it.
This is a very good resource. We have used it, and it's a quite good resource.
In this case, we want students or volunteers to perform little tasks, to perform actual tests. They have their models. I would say that this pendulum will move with these patterns in this scenario, no? And you have your pre-calculated result. You can check with the experimental result of our machine, and also with ideal pendulum with no resistance to the air and so on. Okay, so you can control it. And finally, also another experiment you can use for your research. Here at ViSH, we have a complex physics system groups also running nuclear fusion research. Okay, so this research is done with the TIEMAT national initiative in Spain, and we are analyzing the future of ITER experiment in Cadarache. I don't know if you know ITER. It's a big, huge experiment, international, with the United States, India, China, Japan, Brazil, and the European Commission and Europe. They want to create the first accelerator of fusion in order to generate energy. Okay, it could be a solution for the global climate change and all kind of energetic problems. It is very safe, the nuclear fusion. We are simulating
Is it the first in the world?
There are several devices in Madrid, in Manchester, there is the Jetta in Lausanne, also in Japan. I know many devices, but the big one, the ITER, is the first created to generate continuously energy. Okay, there are many devices creating fusion energy at this moment, but it is a very complicated reaction, the fusion with the deuterium and the tritium. It is very complicated, very complex reaction. Okay, it happened only some part of seconds. Okay, milliseconds of fusion, and they want to create continuously fusion in this case in ITER device. Okay, which is being constructed in Cadarache in the Provence in France. Just to give you an idea, it takes so many energy to run this that it requires a fission nuclear plant in order to give the energy to the fusion device. Okay, it's that's what in ITER they require a fission nuclear plant in order to run continually the fusion experiment. In the next 20 years, they will create after ITER the demo project, which should be the first one isolated fusion device generating as many energy as it requires. Okay, and in 50 years we will have one device able to give energy for the whole humanity. But those 50 years in fusion, I know they are the common issue for the last 70 years. So who knows? But it is a big effort in ITER, and it is nice. So here we have created somehow the showroom of the ITER device. You can see in the top left of the header of the website some beams. Those are the coils of the vacuum chamber where the fusion arises in order to get the plasma, the gas at million of degrees, 200 million degrees of temperature, heated by a microwave, very strong microwave. It is in the vacuum, 2 million degrees, 200 millones de grados. Sorry, those degrees. The vacuum chamber is controlled by the coils with a big magnetic field, and the plasma is I forgot the name. Sorry, it's confined. Sorry, the plasma is confined with those coils. Okay, so at the end, what is a plasma? Million of atoms, okay, running free and colliding one each other. What we have developed here in Zaragoza is the application simulating the position of those atoms. Okay, we have the Runge-Kutta method, the numerical calculus to evaluate the position of each atom at any time step. If they collide, if they are suffering a big magnetic field, different geometry of the device, and so on. It is called ISDEP code, and it is very useful for the ITER device. And we are running also the visualization and the virtual environment to model this. So in this website, the ViSH-TMR.es, you can check the laboratory and perform your own experiments, modifying the the magnetic field, the magnetic mirror, or simulating the ITER.
Yes, there is an application in this website, right? To simulate.
Yeah, you must check the laboratory link in the left, and then in laboratory ITER, for instance, or TINI application for the magnetic field, and it is also a didactical unit for that. Okay, I think everybody's leaving. I don't know if anyone.
Yes, we are
is
running
still
out of
there,
time, but you can finish just with this.
It's okay. I just wanted to send as again. I will send you the links to the tools and the websites, and I'm open for all of your questions and suggestions and whatever. Okay, and I will.
Okay, thank you very much. We will send a report, and also there is a recording with everything in case anyone, because I saw that some people had connection problems, maybe with the iPad or the Wi-Fi. So, and also you can post questions to Fermin or to me or to anyone in the Global Excursion project. So thank you, Fermin.
Thank you.
And if anyone has a question in the chat. Okay, I think almost everybody, there are still five people, but thank you very much.
Thank you.